Welcome to another fabulous edition of Comet Algebra. This video is for Algebra 1, Chapter 5, Section 1, Points in the Coordinate Plane. So this video starts with a whole bunch of terms. And most of these terms should be review from last year, so you decide which ones you need in your notes and which ones you just want to review here on the video. First, we have an ordered pair. A pair of numbers x, y describing a point or location on the Cartesian plane. So the Cartesian plane is just another name for the coordinate plane, meaning the x and y axis, and this flat surface represented by the x and y axis does go on forever in all directions. An ordered pair represents a location on that plane. I don't know, we could just have the ordered pair right here. Maybe it's positive 6, negative 6. So that's the example of an ordered pair. The coordinates are the two symbols in the ordered pair. A lot of times we use x and y, but we could also use other letters like a and b, but just they go alphabetically. So if we were asked to graph an A and B, the A would be like the X number and the B is the Y because it would show up alphabetically. Quadrants. You need to know the four sections that the plane is divided into. We call the quadrant where the X is positive and the Y is positive, we call that quadrant 1, which is represented by Roman numeral 1. Quadrant 2 over here is where x is negative but y is positive. Coming around down here, this is quadrant 3, where both x and y are negative. And here in quadrant 4, x is positive and y is negative. So a good test question would be, in what quadrant are both x and y negative? And you'd have to say quadrant 3. All right, we already know the x-axis goes horizontal and the y-axis goes vertical. So you really need to have it straight in your mind that the first number in the ordered pair is the x number. So the first number is the left or right number, or the, sideways. The second number is the number that we go up or down. This is easy to get mixed up, so keep that straight. We always start here at 0, 0, which is called the origin, another one of our terms. Start at the origin, so the first number goes side to side, and the second number goes up and down. This term isn't used too much, but I've seen it in this assignment, and I think I've seen it one other place in the Algebra 2 book. So just so that you're aware of this kind of funny word, abscissa means the x-coordinate and ordinate means the y. So if you just put it in your notes, you'll have it, and then when they use that in your assignment, you'll know what they're talking about. In example 1, we're asked to state the coordinates and name the quadrant or axis containing the points. So let's look at point A first of all. And I did my best without an actual grid to put them on intersections here. So point A, the first number in the ordered pair is the sideways number, so we're coming in the positive direction, 1, 2, 3, and down 1. So it becomes positive 3, and negative 1 is for the y. And point A is located in quadrant 4. Let's look at point B now. B is up here in the y-axis, so we're not going sideways at all. So the x-coordinate of B is 0, and then we're up 4, so it's 0, 4. Now B is not contained in any quadrant. Over here it said quadrant or axis. B is actually sitting right on the y-axis. Point C. We come over in the negative direction 2 and then down 2, so both the x and the y coordinate is negative 2 for point C, and this is located in quadrant 3. Next we look at point D, which is located in the negative direction, 1, 2, 3, and it's not going up or down at all. So it's just -3, 0. It is not in a quadrant either. It is sitting right on the x-axis. The last thing in this section to talk about is scatter plots. A scatter plot is defined, it's a graph showing a relationship between a set of numbers. So let me just clarify that a little bit. We know that, well, a scatter plot is a first quadrant graph. So it's only going to have an L shape. We're only going to look at the positive x and the positive y. And this scatter plot, if we're plotting two sets of numbers, perhaps we're plotting how much gas we use versus how far we drive. And we notice that the further we drive, the more gas we use, and our mileage varies a little bit. So what this scatter plot is showing is that as x is increasing, y is increasing. It's showing a relationship. Likewise, another relationship a scatter plot could be showing, if we're graphing how fast we drive versus our mileage, because if you don't know this, the faster you drive, you get a little worse gas mileage on the highway. So if we plotted this, it would show a relationship decreasing, meaning the faster we drive, the lower the mileage. So that's to describe what I mean by the relationship. If one's increasing, the other's increasing, or perhaps one's increasing as the other's decreasing. So we're going to be making scatter plots. In this section, we're going to be doing it on paper. Pretty soon, we're going to be putting scatter plots on our calculators. So this example wants us to make a scatter plot with the heights and weights of the students recorded on the table. And so hopefully we'll see a trend here. So let's scale our graph here to show what we need it to show. So I scaled the weight counting by 20 pounds to get up to, well, 140, 160. And then I did a little break in the x-axis here to show that I did not start at 0. So I went 50, 55 inches, 60, 65, and so on. So now let's plot these in a scatter plot. Let's plot a height of 64 inches, would be right about here, to a weight of 130. And I'll just do the best I can without actually having graph paper here. And then let's graph 60 inches to 124 pounds, would be right about there. 62 inches to 138 pounds, right about there. 58 inches up to 98 pounds, right about there. 62 to 142. So we do see a trend, we do see a relationship, and we can describe this relationship as the taller a person is, the more they're going to weigh, because we see the trend is increasing like this. So now you have all the knowledge you need to do section 5.1, so have fun.